In these problems, we're going to see how we can use trig to find unknown parts of right triangles. So in this problem here, we have this section here, this piece of the right triangle that we're trying to solve for, which is x, and we've been given the base length here, and we've been given the two different angles that comprise these two triangles. So you have this non-right triangle that's been kind of placed on top of this right triangle, and we have a larger right triangle here. And that's the key, is to recognize that we have this larger right triangle. So we need to come up with a strategy. How do we find this section here, right? This section right there. Well, really what would be ideal is if we could find this length, and if we can figure out the length of the whole side, then we can find the difference, which would then be the value of x. And we can do that here because we do have this angle here, which allows us to get the ratio, okay, convert this into this ratio of this length to this length, which allows us to find this unknown length here. And we can use this larger right triangle, and I'm just going to highlight the larger right triangle. We're going to use this larger right triangle with an angle of, in this case, it looks like 73 degrees to figure out the entire length of that side. Okay, so the first thing is then we're going to work out the length of this side, and we'll just call this side y. And if I look at this smaller right triangle, and again we have to use right triangles, we can't use this 25 degrees on its own. This right triangle has an angle of 48 degrees. It involves the side y and tan. That's opposite and adjacent. If I go to my SOHCAHTOA, that is my tan ratio. So I'm going to start with that. So I'm going to say the tan ratio of 48 degrees is equal to, okay, the opposite over adjacent. Okay. So in this case here, we have our tan ratio. We now, as with an unknown, so we need the actual value of that tan ratio. Now to figure out the value of the tan ratio, I can just go to my calculator. My calculator will allow me to go from this 48 degree angle shape to the ratio of the two sides. And the ratio of the two sides works out to be 1.111. Okay, so I'm going to write that as 1.111 compared to 1. Again, although my calculator only gives me one number, we have to recognize that tan ratio is always a comparison of two numbers. And then I can solve this algebraically. You know, I can use a multiplier here. I can go from bottom to top. It's going to be times by 1.111. We can cross multiply and solve algebraically, and we can see that that's equal to 11.11. Okay, so we have this length of 11.11, and I'm going to then figure out the length of that entire side here. And to do that, I'm going to use a yellow triangle. And again, I'm going to involve the two sides of opposite and adjacent, and I'll call that length Z. Okay, and those two lengths are going to involve this angle of 73 degrees when I add those two angles together. So again, since it's opposite over adjacent, I'm using my tan ratio. I'm going to use a combined angle of 73 degrees because I need to use an angle in the right triangle. It's going to involve the sides opposite and adjacent. And from my calculator, I need something I can work with. I need some ratios. I need to convert that angle into a ratio. So I go tan 73 degrees. I end up with 3.2708, or so I'm going to round that to 271. So 3.271. And again, although there's only one number, we know that that number really is a comparison to 1. And then solving algebraically for Z, I get 32.71. So this length is going to be 32.71. I could go ahead and solve for x. I know that length of x is a difference of those two sides, so x is equal to the long side minus the short side. That a little bit better. 32.71 minus the shorter side, of 11.11. So my length of x that I've calculated here works out to be 21.60. Okay, so there's the length, and we can find that by finding parts of, well, we can break it into right triangles and find the unknown sides of right triangles and then find the difference. So solving for triangles means find all the angles and sides. So here we've been given two sides, which then gives us an idea of what the shape is. We need to find the hypotenuse, which we can do through Pythagoras. And then we need to be able to use the shape from the ratios and convert that into an angle shape. And we're going to need a calculator for that. So first things first, I'm going to solve for x. So I know that's the long side, so the hypotenuse. So I'm going to add the squares of these two sides. So when I work that out, I get 19 squared and 14 squared. Okay, so 361 plus 196. Okay, so I get this. The x squared is 557, so x equals square root of 557, and so we're just going to use square root 557. Okay, so if we actually work that out as a decimal, and again I want you to get in the habit of using the exact values, so that's approximately 23.6. Okay, so leave that. I'm going to leave that exact value. Again, I encourage you to keep it as exact value. So length is going to be square root 557. Now we need to work out the angle. To work out the angle, we have to figure out the shape based on an angle, which means then we need to convert the length description or the ratio description of the shape into an angle description, so we need a calculator for this. So I'm just going to use my tan. So I'm going to say that tan of angle A is equal to the slope 19 over 14. I need to solve for the angle, so I need to do the opposite of tan. Okay, so I'm going to give the calculator the tan ratio. The slope, the input is 19 over 14. And my output needs to be the angle, so I need to use arctan in this case. So 19 over 14, that should give me an angle of, I'm going to estimate it to be maybe, it's going to be more than 45 because I know the ratio of 1 to 1 is 45. So I'm guessing it's maybe about 50, and my calculators give me a value of 53.61. which I'm going to round to 615, so I'm going to round to 62 degrees. Okay, so 53.62 degrees. Now, once I find one angle, I know that these two angles, B and A, are complementary or add up to 90 degrees, so I can subtract from 90. So that would be the easy way to do it. I could also, alternatively, I can just use the fact that the arctan of the reciprocal slope, okay, so 14 over 19, that's the reciprocal slope. The arctan of that is going to give me angle B. And if I do the arctans of reciprocals, I always get complementary angles. So this angle B, okay, which is going to be this angle here, should be 46.38 based on 36.38 based on the complementary nature of angle A. And my calculator, okay, when I put that into my calculator, I end up with 36.38. Again, we didn't need to use the inverse trig function to find this because of the complementary nature of these two angles. These two angles must add up to 90 degrees. Okay, so we can always work that out. We don't need to use inverse trig to find that angle. We can just subtract from 90 degrees to find that other angle.